There's a lot of different types of factoring. The very first type of factoring that's usually taught is the greatest common factor. Then sometimes like difference of squares. And then somewhere around 3, it could be 2 or 3, is this a equals 1 case for x squared plus bx plus c. There's a 1 that's right there, and that's what this refers to. So the goal here is to find two numbers that multiply to 7 but add up to 8. So you write the factors of 7. There's only two of them. Hopefully you've seen this before. So you write x plus 1, x plus 7. That's the most basic type that you can see of this example. Is that something you've seen before?
Yeah.
Okay. So I call that, I've got a factoring worksheet up on one of my student resources that you could use to help prepare for this test. But the second type I'm going to snip in is 27. So the first one was this, I call it the plus plus case. This one is the minus minus case. And you see that here because this is a minus and this is a plus. So your answers end up being x minus something, x minus something. It's the same game though. You've got to find two numbers that multiply to 18, but add up now to -9. That's where these negatives come in. So it's like -1, -18, -2, -9, -3, -6. And these right here, they add up to -9. So I call it case, or case 1 is plus plus. Case 2 is this minus plus that we just saw here. So case 3 and case 4, they're either this plus minus, or what you'll see is minus minus in the factoring. These are the hardest ones, so we'll do quite a few examples of these because they're a little bit more difficult here to work through. And because we're doing this virtually, if there's anything that's unclear, please just pause and say, I didn't get that, or could you do that again, or give me another example. It's all got to be done verbally because I don't have any way to see your body language to know if you're understanding or not.
Right.
So this is the minus minus case. So you're looking for two numbers now that multiply to -7. And you'll notice there's two possibilities, -1 times 7 or 1 times -7. Which of these adds up to -6? Well, it's this one. So that's +1, x plus 1, x minus 7. Now, if you're ever unsure of your answer, you can always FOIL to check. So if you were to FOIL this, you should get back to the original. And that's a good thing to do on an exam if you have the time. Sometimes you have the time, sometimes you don't on the exam. So leave it at that. Number 30 here. Number 30 here is another one of these. It's case 3 and 4. This one, you're factoring x squared plus 3x minus 18. So two numbers that multiply to -18. There's quite a few options here. -1 times 18, 1 times -18, -2 times 9, 2 times -9, -3 times 6, 3 times -6. I like to write them all. Generally it's the ones towards the end or the middle here and the beginning that are correct, but it really could be any of them. So writing them out, you know for sure that it's there if you see one that adds up to +3, and that's this case here. So that's x minus 3, x plus 6. Out of everything we've done to this point, is there anything you would like me to review again or do more examples of, or what do you have in mind?
No, I think I got everything so far.
Okay, excellent. All right, so we're going to move on to something I probably should have done first. The very first type of factoring that is usually taught when you're doing factoring is the greatest common factor, GCF, greatest common factor. And the greatest common factor can either be a number a letter, or both. So generally what you're looking for GCF is you're looking for numbers, letters, or both. So from 44, 3x squared minus 24x minus 27, is there a number that's common to all three of them? There is. It's 3. So x squared minus 8x minus 9. Now I could have given you this problem previously because you know how to factor these now. You know to find two numbers that multiply to -9 but add up to -8. This 3 though, it just hangs out on the outside. Just hanging out on the outside. So two numbers that multiply to -9. So we have options here. It's 1 and -9, -1 and +9, 3 and -3. Do any of these add up to -8? Yes, the first one there. So this 3 just stays. It stays on the outside. X, this is +1, so +1, x minus 9. All right, so number 45 here. 45 has, actually we're going to do that last. We're going to do a different one first. I'm sorry. So this is an example of a GCF that is a letter. Okay, a letter here. See how there's an X in all three of these?
Mm-hmm.
The X is your GCF. So you're going to bring that to the outside. X squared minus 10x plus 25 is your trinomial. So this is the thing you're trying to factor. You're trying to find two numbers that multiply to 25 but add up to -10. So when you see a negative here, whenever you see negative plus, your answers end up looking like this: x minus, which means both numbers are negative here. So it's like -1 and -25, -5 and -5. Do either of these add up to -10? Well, it's this one. And see, the negatives already been accounted for with the subtraction symbol. So you put 5 and 5. You can read it as -5 or -5. It's up to you. And then you bring this x down. So we've done an example here. 44 is an example where the GCF is 3. It's a number. 46, the GCF is x. It's a letter. Well, now we're going to do an example where it's both a number and a letter. I'm going to snip that question in here. Okay, so first thing you should know about GCFs is it's okay if you don't get it all together to start. So and a lot of times the number is just the number out in front. So let's factor a 5 out. Okay, that's x cubed plus 6x squared plus 8x. Like, it's okay if you just do that, because then you're going to say, oh, there's an x in every single term. So you factor an x out. So you have a 5 here, and then you grab the x, and you say, well, what's left over? Well, it's x squared plus 6x plus 8. So if you were to distribute this 5x into each term, you would get back to the original, and that's your check. You know, if you need it, if you have time, etc. So this is the plus case. That means it's going to be x plus something, x plus something. Two numbers that multiply to 8 but add up to 6. So this could be 1 and 8, 2 and 4, and that's it. Do either of these add up to 6? Yes, this one does. So that's where the 2 goes, that's where the 4 goes. 5x. So we've completed kind of another section grouping of questions here. I'm going to move on to a new type of question, but is there, would you like to do more examples of that?
No, but just a quick question.
Of course.
Can a number that you factor out be negative too?
Yes. So like an example of that, just to see it. So we have like minus 2x squared minus 10x minus 50. So the negative 2 comes out, so that's x squared plus 5x. Actually, let me change this number to sorry, let me just change a couple numbers here so that we can factor it. Okay, so we would have 10x here, and then plus 25. Okay, if you factor that negative, you multiply in, you get back to the previous numbers. And then this is two numbers that multiply to 25 but add up to 10, so that's x plus 5, x plus 5. Okay, there's this question that for me it feels like it's out of scope for what you're doing, but it's like the backwards of the questions that we've been doing. So that's why the instructor put it here. Do you think this will be on your exam? Should we cover this?
Yeah, it will be.
Okay. So the idea here is if I give you a trinomial and I ask you to factor, you can get these numbers. Okay, this is going the other direction. So what they're effectively saying is that x equals -7 and x equals 9. That's what it means by these are the solutions. So whatever numbers you get on your exam, you're going to write x equals whatever that first number is, x equals whatever that next number is. The next thing you're going to do is you're going to move these to the other side. So you're going to add 7, add 7. So this is x plus 7 equals 0. Subtract 9, x minus 9 equals 0. These right here that I'm putting in parentheses, these are what you're going to multiply together. X plus 7, x minus 9. You're going to multiply them. And that's where you're going to FOIL. Is FOIL something you're very comfortable with?
Yeah.
Okay, so it's x squared minus 9x plus 7x minus 63, x squared minus 2x minus 63. So if you were to factor this, you would get back to this line here. This FOIL and factor are very much related. Okay, so I want to just have you jump in here. Let's say the solutions are -5 and +3. Give you 60 seconds. Can you come up with the quadratic that these come from?
Could you just show me like how to start?
Yes. So notice in the previous problem, you write x equals -7 and x equals 9. Those are the two solutions here. So here, I tell you the solutions are -5 and 3. So I say write them, right? X equals -5, x equals 3. Then you're going to move them to the other side of the equation. So it's going to be x plus 5 equals 0, subtract 3, x minus 3 equals 0. These become your two factors. And then you multiply them together, x plus 5 times x minus 3. So that's x squared minus 3x plus 5x minus 15. Would you like one more like this to do, or would you like me to move on to something else?
I think one more like this.
Okay, so the solutions this time are -4 and +6. Oh, I didn't even simplify this one's x squared minus 2x minus 15.
So would it be x squared minus 2x minus 24?
Sounds right, because you're gonna have x plus 4 times x minus 6, x squared minus 2x minus 24. Yeah, good. All right, so we're gonna move on to something else that I guess is it's related. There's sort of a path to learning this that we can improve upon from what we've got here, but this is all we have. So this one should say solve by factoring. Because whenever you have an equal sign, you're solving. The instructions here just say to factor. If that were the case, we wouldn't have this. So I don't really know what the instructor wants here, but this is an example. It's the last one we'll do of a GCF followed by an a equals 1 factoring. When you look at 7, 14, and 105, what GCF stands out at you as a possibility?
7.
7. Question is, does 7 go into each of these other ones? Well, we know it goes into 7 and 14. Does it go into 105? Well, maybe if you had a calculator, you could do it real quick, but 7 times 10 is 70, and that leaves 35 left over. Well, that's 7 times 5. So you can see that's how you get 15. 15x squared. But there's more. There's a letter that's common to each of these, and it's more than a letter. It's a letter to a power. So do you see how there's an x squared in each of these?
Mhm.
So from here, x to the fourth, to get back to x to the fourth from x squared, you need an x squared here. To get back to x cubed, you just need an x. And from here, you need just a 15. I would ultimately like you to be able to go to this step here, but I'm okay if you need to do it in 2 steps. It just depends what you see, what you're comfortable with doing. But notice if you distribute in this 7x squared to each one, you get back to the original. And that's your check. That's how you know if you've done it correctly. So I'd like you to try this one on your own, please. Factoring this. 2 numbers that multiply to -15 but add up to +2.
-3 and 5.
Yes, so it becomes x plus 5, x minus 3, and then you bring this 7x squared down. Very good. Okay, we're going to transition to the type of factoring that's usually more challenging for everyone. It's the a not equal to 1. It's where the first number in front of x is not a 1 and there's no GCF. So it's It's a very different type of solution. So notice this is not 1 in front, it's a 6, and this number doesn't go into each of the other numbers. There's nothing to factor out here. So this is a not equal to 1. There's really two techniques. The first is kind of this guess and check, which not as good as doing using grouping. Grouping is, I think, what's taught now, and hopefully you've seen that in class. So to use grouping, what you do is you take this 6 and this 4 and you multiply them together. That's 24. So you write that over. 6 times 4 is 24. This time you're trying to find two numbers that multiply to 24 but add up to 11. So that part's kind of the same, but it's not based on this number. So we could write them out: 1 and 24, 2 and 12, 3 and 8, 4 and 6. So do you see how these add up to 11?
Mhm.
So this is the crucial part. This 11x becomes these two numbers, 3x plus 8x. These other things just come down: 6x squared plus 4. Have you seen this before?
Yeah.
Great. So now we're going to do what's called factor by grouping, or I call it, it's like double factoring because you do it twice. You look at the first two terms and you figure out what's common between them, because it could be a number, it could be a letter, it could be a number and a letter. Can you tell me what's common between both of these?
3.
3, very good. A little bit more though. There's also an x in both.
3x, yeah.
Yeah, and that's where that's really critical that you get these right. So this becomes 2x plus 1 inside here. Now you immediately take this and you write it over here, whatever's inside parentheses, 2x plus 1. And you figure out what goes here so that when you multiply in, you get back to the original 8x plus 4. So what number times 2x gives you 8x, and what number times 1 gives you 4?
4.
4. Now, if those don't work out perfectly, most likely you've made a mistake and you just go back and check. It's rare that you get something that doesn't factor in these cases, although it's possible. So now, this is why I call it double factoring, because we kind of factored it once. Now we're going to factor it again. So these 2x plus 1s, they're common in both. So you end up writing that out in front. And then what's left over? Well, this 3x is left over, and this 4 is left over. And they come down here like that. We're going to do a bunch more. So if there's any part of that wasn't clear, we're going to do a bunch more, and it will become clear, I hope, after all of this. I'm big on recipes or steps, and I try to teach things in a way where it's like, do this, then do this, then do this, and that will get you there most of the time. So for these, this is the a not equal to 1. That's 2. 2 doesn't go into each of these, so you can't factor it out. So that means you've got to do this grouping approach. Okay, so your grouping approach means you take this 2 and this 10 and you multiply. 2 times 10 is 20. Two numbers now that multiply to 20 but add up to -9. So since they're negative, these have to both be negative. -1, -20, -2, -10, -4, -5. Okay, we found it. All right. So you take this -9x and you break it apart. -4x minus 5x plus 10, 2x squared. You just bring those down. The order doesn't matter here. There's kind of a preferred order that you'll see if you do more of these, because it'll work out more nicely, but the order doesn't matter. So now that you've done this, because this just goes back to the previous step, if you just combine them, you have to factor out the GCF here. So what is the GCF between 2x squared and -4x? It's a number and a letter this time. What do you say?
2x.
2x. So this becomes x minus 2. So you immediately take this x minus 2, whatever's in parentheses, and you write it over here, x minus 2. And you ask yourself, what do I put here so that when I multiply in, I get back to these previous ones? And what do you say about that? Sometimes the number is easier to get back to 10. It's up to you, whichever way you look at this. What number times 2 gets back to 10?
5.
5, but we want to go from negative positive, so it must be negative 5. Because negative 5 times x gives you minus 5x. Then, so now the last step here is you take each of these, which is common to both, and you write it out front. And then you bring the other ones in, 2x minus 5. Okay. So now I mentioned this over here. I said you could do this in either order. So let's say you got down to 2x squared, and you said, well, I'm going to do minus 5x minus 4x plus 10. Do you see how all I did in this line is I just switched the order here? Now, what's common between 2x squared and minus 5x? Just an x. 2x minus 5. And you immediately write that over here, 2x minus 5. What do you put here so that when you multiply in, you get back to the previous line? Negative 2. And then I mentioned this over here on the left. You take this 2x minus 5, 2x minus 5, and you write it out front, and then you bring the other ones, x minus 2. These come down. And I ask you now, are these the same?
Yeah.
They're just in a different order. So it doesn't matter which order you do them in. All right. Just trying to find the next one. There's the nice, like when you do these in a certain order, you get a nice increasing difficulty for them. Okay, we did not do this one, did we? Okay, no. Sometimes I can't tell which one I'm doing. Okay. Again, this is a not equals to 1 because there's a 2 in front. Well, it can't be 1, and 2 doesn't go into each of these. The first step is to take the 2 and the 10 and to multiply them. I'm sorry, did we just do this? Why am I? We did. I'm so sorry. It looked different. Oh, that's because I looked at the wrong one. Okay, I'm sorry. We're gonna go to 19 next, or 18. We'll go to 18 next. There it is. Okay. So I'm going to have a little bit more of your help this time on this one. Again, the 3 doesn't go, it goes into 24, but negative 24, but it doesn't go into 14. So you got to multiply 3 and 24. So this is where the numbers get kind of not great. This is negative 72. So now we got to factor negative 72. Are you allowed to use a calculator on this?
Usually, yeah.
Okay, so you can quickly come up with these. You just have to divide this number by a bunch of things. So it's up to you if you want to alternate these negative signs, but it's good for me to show you this. So it's 3 and negative 24, negative 3 and 24. I'm going to come up to the side here. 4, negative 4 and 18, 4 and negative 18. And I'm going to stop here because I found it. Do you see how those add up to 14?
Yeah.
And the important thing here is this negative goes with the 24. That's why it's negative 72 here. So we're breaking apart this 14x. We're saying 14x is really minus 4x plus 18. Now, you have a choice here. It's either minus 4x plus 18, or it's 18, I'm sorry, x, or it's 18x minus 4x. Which do you prefer based on these numbers here?
Probably 18x minus 4x.
I agree. I like that a little bit better. So we're going to bring that down, minus 24. So you grab the first two terms and you say to yourself, what is common between them? Number and a letter.
6 or 3x.
3x. That becomes x plus 6 inside. Where does this x plus 6 go?
You write it over on the other side?
Yeah, you immediately just write it over here. And then you're filling in this placeholder for it. You ask yourself, well, what do I multiply in? What do I multiply in by to get back to the original? What would that be?
Negative 4.
Very good. Then you take each of these and you say, I'm going to condense it down into one and rewrite the other stuff in there. All right, so this is now, I want you to try this one on your own and just get as far as you can. I would love for you to solve it. If you can't, we'll do it together, of course, but I want to see if you can do this on your own. If you need me to, I can show some of the notes up here. But give yourself, 60 seconds and see how you do on that. How are you doing on this?
I got 1x minus 12 times x plus 1.
Okay, so I'm sorry, 1x minus 12 times, say that again, 2x.
Or just x plus 1.
Okay, so the times x plus 1?
Yeah.
Okay, so if I were to FOIL this, I would get x squared minus 11x plus 12. I wouldn't have that 2 out in front. So I already know there's something not quite right here. So let's take a look together. 2 times 12 is 24. So we want two numbers that multiply to 24 but add up to negative 11. It's negative 8 and negative 3. So I'm going to do it this way. 2x squared minus 8x minus 3x plus 12. Did you have this line written down?
No, I used 1 and negative 12.
To get to for the 24?
Yeah.
Okay, so because it's negative 11 here, both of these numbers have to be negative because it has to multiply to 24. And what I heard you said, negative 12 and positive 1, they don't multiply to 24. They do
Oh,
multiply to 12.
right.
And that's what's confusing is because you're so used to dealing with that number, and yeah. What you have to do is train yourself. If it's a equals 1, I do this. If it's a not equal to 1, I do this. And like on one of the approaches you could take on your quiz or exam tomorrow, test, whatever, is you could do all the ones that are this way first, and then do all the ones that are this way next. That way you're doing them the right way over and over again. So go ahead and start the problem again from here and see what you come up with, please, from this position.
So 2x minus 3 times x minus 4.
Yeah, so 2x here, and that gets you the x minus 4, and then x minus 4 minus 3. That's exactly right. Excellent. Okay. We've got a few more to do, so you get more of an opportunity to work on these. All right. So let's look at 32 here. Okay. And 32, this is something that I really emphasize is the very first type of factoring you always do is GCF. So like above all else, like this has to be your guiding list. Does this thing have a GCF? And the answer is yes. What is the GCF here?
2.
2, but I'm going to put a negative because there's a negative out in front.
Mm.
What about a letter? Is there a letter that's common to both? All three, I mean,
X.
X. And it's always the smallest exponent, just in case I didn't say that earlier. So can you tell me what goes in here? This is crucial that you get this.
It would be just negative 2x
So this is
minus 5.
2x squared.
Oh, square, yeah.
Yeah, the negative 2 times 2 gets you back to the negative 4. X times x squared gets there. Okay. How about here? I think I heard you say plus 5.
Yeah, plus 5 square, or x.
5x, okay. And then the last one here?
Plus 3.
So plus 3 would get you back to, so I wrote negative 3 because a negative times a negative gets you back to the positive. So what I'm going to suggest here, and I appreciate you scheduling before the exam. If we had more time, meaning if we had done a lesson like last week, I would definitely spend more time working with you on making sure this is clear, because what you just said will produce something you can't factor, and then you'll feel really frustrated on the test, which is the last thing I want. So what I'm going to suggest is when after you do the step, multiply in and right over here to the right, whether it matches for that. So this is if we look at just what's here, 2x squared plus 5x minus 3. This is an a not equal to 1 because the 2 doesn't go into these. 2 doesn't equal 1. You're going to multiply 2 and negative 3. 2 times negative 3 is negative 6. So now you look at this number here, two numbers that multiply to negative 6 but add up to 5. So like negative 1 and 6, 1 and negative 6. Negative 2 and 3, 2 and negative 3. Notice how each of these have to multiply back to the original, and we're finding the one that adds up to 5. Which one is it in this list?
Negative 1 and 6.
Negative 1 and 6. So this one breaks apart into minus 1x plus 6x. There's always an x with it. Bring down the minus 3, bring down the 2x squared. So what's the GCF here between those two? 2x squared minus 1x.
Just x.
Okay, agreed. 2x minus 1. And you immediately write that over here. What goes on the outside so that you can multiply in and get 6x minus 3?
3.
Plus 3. So this becomes 2x minus 1, x plus 3. But wait, this minus 2x has to come down here. So it becomes minus 2x on the outside. All right, we're going to do another one. And this one is very much like the previous one. What is the very first type of factoring you're always supposed to do, according to Matthew?
GCF.
GCF, yep. So we're looking for a number that goes into all threes. And this is where it's a bit troubling. Like, let's just say you didn't know anything really, and you're like, I don't even know. Let's just try 2. Does 2 work? Like at 9x squared minus 60x minus 21. You still have to see, can another number go into these 3? And another number does go in, which is 3. So imagine that there's a 3 on the outside. That's 3x squared minus 20x minus 7. So if you don't know the GCF, you just try something and then you can keep doing it. It's not an all or nothing shot. You get as much grace as you need for this. So now, if you're down to this point, because you could just go right from the beginning with 6. I mean, obviously, would love for you to go down to this point without these previous 2 lines, but if you need them, that's fine. This is an a not equals 1 because 3 doesn't go into each of these, and 3 is not 1. Which 2 numbers do we multiply together?
The 3 and the -7.
Right, and that gives you negative 21. This is where you got to remember, you're looking for something that adds up to negative 20. So it's negative 1 and 21, 1 and negative 21, negative 3 and 7, 3 and negative 7. This one adds up to
Negative 20.
negative 20. So that's 3x, I'm sorry, messing this up, the order. So this negative 20 is what breaks apart. It breaks apart into 1x minus 21x, and then you bring the 7 down, you bring the 3x squared down. And that's kind of blending in. Make that a little cleaner. Okay, so now between these two terms, what's common between them?
Just x.
X, and that becomes 3x plus 1. You immediately write that over here. A lot of repetition what we're doing. What do you multiply each of these by to get back to the previous line?
-7.
Negative 7. So these 3x plus 1's come together. X minus 7. And then we have to bring this down for your final answer there. All right, so I'm gonna have you try this one on your own and just give you like a minute. If you can't do it, that's okay. We'll still work through it. I think a really good practice would be to redo most of these that we've done today before the exam. Not right now, but maybe before you go to bed. Give this one a try. It definitely has a GCF. I'm just going to start writing out a couple of steps here, and you can let me know if something isn't similar to what you have. How are you doing compared to this?
That's about how far I got.
Excellent, excellent. Okay. I think you're well on your way here. Were you able to get to this last step?
Yeah.
Great. Okay, so we're going to talk about one more thing, but before we do, I want to remind you that GCF is the most important type of factor. It could be a number, could be a letter, could be both. Most of the factor we did today fell into two types: A equals 1, A not equals to 1. And these are the ones you do by grouping. You definitely want to practice a few more of those. There are exceptions. You know, a lot of math is about exceptions. If you just ignore the exceptions, you can get about 80%, maybe 90% on certain tests, but there is an exception here. The exception is what's called sum of squares. So if I asked you to factor x squared plus 9, the fact that there's a sum here means that this is not factorable. If I gave you x squared plus 16, it's the same case. It's not factorable. Your book gives you an example for x squared plus 9. This is also not factorable. There is no such thing as sum of squares that factors. So if you see two terms and a plus, you write not factorable.
And then I think there was something that she mentioned in class. It was difference of squares.
It's not on this worksheet though.
Okay.
So you might maybe send an email today and say, I didn't see it on the worksheet. Is it going to be covered on the exam?
Okay.
This takes us to the end of our lesson. I'll send you the notes and the screen recording out shortly. Thanks again for scheduling. And if you ever need a time that's not available, text me or send an email and I'll add it for you manually. But thanks for rescheduling. I'm glad it worked out for you and hope your exam goes well tomorrow.
Thank you.
Thank you. Bye now.